left off at number 37.
Yes, we did.
So,
Answer was like 13 or something like that.
find the inverse of this matrix. So what's the process to find the inverse? What do you do first? Find the determinant.
Right.
That's the first step. Okay? So we have negative 8 minus negative 10, which is plus 10.
There it is.
Right? Negative 8 plus 10 is 2.
Yeah.
And then you make it 1 over that determinant.
Yeah.
Okay? And you multiply that times a new matrix. And how do I find the new matrix?
You're going to switch the places of the 4 and the negative 2, and then you're going to switch the signs. There you go.
Okay? And then I distribute that 1/2 in. So my new matrix, my inverse matrix, is negative 2/5, negative 1. Sorry, not negative 2/5. Jeez, losing it. Negative 1, negative 1, 5/2, and 2. Okay, so on the final, if I have a little note to the side of it that says must do by hand, I need to see this work. But once you do the work, how could you check it? Yeah, and how do you find the inverse in a calculator?
You plug it in, and then you...
Then what? So you put it in the calculator as a matrix. So let's all practice.
Maybe just a half...
You're going to go to Edit. This time it's a 2 by 2. Enter in 4, 2, negative 5, negative 2.
You mean 1, right? Oh, 4, 2.
Clear your screen. And then do second matrix. Bring in that matrix you just created, labeled A, and then just raise it to the negative 1, which is that X to the negative 1 button.
Oh, yeah.
And hit Enter.
Wait.
Just take that matrix you create and raise it to the negative 1, which is this button here.
Got it?
Okay? And then you can check it, and it's right.
Oh.
Right? Because it's negative 1, negative 1, 2.52. Okay? So this one, now we're moving from solving systems with Cramer's rule to solving systems with inverse matrices. This is the strategy I like to use if I'm going to try and do something really quick on a calculator with a 3 by 3. Okay? So technically, if I wanted to write this system as a matrix equation, I would write the coefficient matrix. There is no y term, so it's 0. And then 4, 1, 6. Everybody see that's the coefficient matrix?
Yeah.
Then I would just write my variables, and then I write my constant matrix. Okay, so just like solving any equation, if I want to isolate the variable, I have to multiply this by its inverse. Because when I do that, it just gets me 1, or the identity matrix in this case. Okay, so I'm going to do it on this side. I'm just going to call this matrix A, so this is the inverse of A. Okay, and then I have to do exactly the same side because the order matters with matrices. So I can't take this times the inverse matrix. I have to take the inverse matrix times this. Okay. Okay, so to solve this system, all I need is the inverse of this times this matrix. And they give me the inverse.
Wow, look at that.
Okay, so all you have to do for this problem, plug this in for your first matrix, 3 by 3. Plug this in for your second, 3 by 1. Multiply the two together on a clear screen, and you have your answers for x, y, and z. No calculator, Stephen, on those.
Is that one number 2 or negative 2?
Where?
On the A1, down, right there.
Oh.
Oh. How will that supposed to go?
maybe just a half a drink more.
Please no. It's just a
Okay, what everybody get?
bigger one.
We're not done yet. Is that 29? Yeah.
It's 3.1.
Okay, so 8 to the negative power times. I got 156, negative 125, and 233. Those answers are probably wrong.
So let's check your, I'm going to do it real quick and tell you what I get. 29. So I'm going to take A times B. I get 4, negative 5, and 3.
Wait, we don't have to do the negative one?
No, it's already given to us.
Oh,
This is the inverse of that. So if you plugged this in your calculator,
okay, I get 4, negative 5, and 3.
yeah, and then took the inverse of it. Yep, 4, negative 5, 3.
I did the inverse.
Yeah, so you did the inverse of the inverse.
Yeah, that's not right.
No.
I told you my...
Everybody get the answer? Okay, so you understand that system and how to do it. So if you aren't given the inverse and you want to solve a 3 by 3 using the inverse matrix, you take this, you put it in the calculator, you raise it to the negative 1, you multiply it by the constant matrix, and your answer's right there. You can do it in like 20 seconds instead of spending a whole page of paper doing the elimination method. Okay? Okay, so to do this one then, if I'm going to use the inverse matrix, I'm going to find the inverse of this, multiply it on this side. So then I take the inverse of this and multiply it by this. Okay, so in the calculator, go to matrix, edit. This is a 2 by 2. I just put in the 4, 6, 5, and 8. Then I go ahead and put the second one in as a 2 by 2. Clear my screen. Pull in the first one, raise it to the negative 1, times the second one.
I got 13, negative 7, negative 8, and 5.
Yep. See how fast that is?
Quick,
Yep.
easy.
Yep. Okay. On to solving this equation. There's no middle term, so I can go ahead and move the 5 over. Divide both sides by 4. I have x squared equals negative 3.
Square root.
Yep, square root both sides. So x is equal to plus or minus the square root of 3, I.
At some point, can we go over what I1, I2,
Mhm.
I3 is?
Okay, next question. Write the expression as a complex number in standard form. Okay, so this one, remember, if you have a constant and then plus or minus an imaginary number, you cannot just multiply the top and bottom by I, or in this case, 4I. It doesn't work. You must use the conjugate. So the conjugate is 3 plus 4I, and I have to do it to top and bottom. So on top, I'm going to FOIL. 8 times 3 is 24. 8 times 4I is 32I. 7I times 3 is 21I. And 7I times 4I is 28I squared. Don't forget the I squared. What is I squared again? Negative 1. So all this does is just make this negative 28. Okay? Then I combine my like terms. So in the numerator, I have negative 4 plus 53I. In the denominator, 3 times 3 is 9. 3 times 4I is 12I. 3 times negative 4I is negative 12I. The i's drop out.
So
negative 4i times 4i
16i.
I squared,
I squared. So it's
which is
positive
plus,
16.
yep. So I have 25 in the denominator. Okay, now I break this apart, so it's negative 4 over 25 plus 53 over 25i. Simplify if possible, but it's not. How did they get? I don't have any one of these with a negative. Why is that? I mean, this is the closest to it, but this one should be
Wait,
negative.
why is your... I think I see your issue.
What?
Because your top ones, there's no negatives. You have negatives on top.
What do you mean?
Okay, so your...
I have 24 minus 28.
Where do you get 20 minus though?
7i times 4i is positive 28i squared, and I squared is negative 1, which makes it negative 28. 24 minus 28 is negative 4. So I think this is an error. I think it's this answer, but I'm just going to fill in a negative.
We can do that on the test.
Yep, or just call me over if you have a question. Okay. This one, don't get caught up in thinking you're having to rationalize this. Because the denominator is the square root of 64, which is what? 8. So I just have a real number on the denominator now. So I have the square root of 245 over 8. Now I want to simplify 245. Well, I know for sure 5 goes in. That's usually what I jump to when I have a number that ends in 5. So I just take 245 divided by 5, 49. So this is the square root of 49 times the square root of 5 over 8. The square root of 49 is 7.
7 to the square root of 5.
Yep.
Your answer, 8. Look at that.
Okay, here is the question you had. Go over the I to the exponents. Okay, so remember, I to the first is just I.
Okay.
I squared is negative 1.
Okay.
I cubed is negative I.
Okay.
I to the fourth is 1.
Okay.
And then they just repeat.
So it's 1, negative 1.
It's I,
It's I.
negative 1, negative I, or 1, yeah.
Okay.
Okay, so every fourth they repeat. So the trick to simplify these is figure out the remainder after 4 goes in the exponent. So 4 goes in one time, but the remainder is 3. So this is I cubed, which is negative I.
1, negative I. No, 1I, negative I, 1.
I,
I,
negative 1.
1, negative I, 1.
And if you can't remember it, I to the first is I to the second is just I times I, which is the square root of negative 1 times the square root of negative 1. Anytime you multiply 2 square roots, it's just the radicand, which is negative 1. That's I squared. I cubed is I squared times I, which is just negative I. And then I to the fourth is I squared times I squared. Negative 1 times negative 1 is 1. So you can derive it, the first 4, real easy if you can't remember. So let's just do another one here.
That would be
Divided by 4 is,
negative 1, 3.
the remainder is 1.
So it's just I.
Negative,
Oh, it's
it's just going to be I.
Mhm.
I feel like you should have a poster on that wall.
Okay, rationalize the denominator. So do I just multiply by the square root of 5?
No.
No, I multiply by the conjugate. Okay, so in the numerator, it's just 2 minus the square root of 5. In the denominator, I have 4 minus 2 square roots of 5 plus 2 square roots of 5. Those go away, which is the point of the conjugate.
Minus square root of 25.
Minus 5.
Right.
Square root of 5 times the square root of 5 is just 5.
Right.
So this equals negative, it's a negative 1 in the denominator. So if I divide everything by negative 1, I get negative 2 plus the square root of 5, right? If I want to get rid of my denominator. And my answer choices, yeah, the one that matches this is this one.
Yeah, 5
Just
minus 2.
commutative property with it, right? Okay.
Ow!
And that's the last problem.
Woohoo!
Okay, so what kind of things do we need to review still? What are you still hesitant on?
I have a trouble with the square roots.
Simplifying square roots?
I mean, like, I understand how to do it, but when I get to the test, I'm like, Kramer's rule. Yeah, Kramer's rule. No, I'm easy. I'm good at Kramer's rule. I just feel like maybe we should just do some extra rule. If you could go over the brackets again, like if you have a big bracket and how they all multiply against each other.
A big bracket.
Matrices?
A matrix?
Yeah, the matrices.
Okay, so you want to review multiply matrices.
Yeah.
Okay. As soon as this clears off. And you want to review simplifying radicals
And Kramer's rule.
and then Kramer's rule. Okay. Can it be simplified?
No. Yes. By 10.
So it's what?
Just a little bit, yeah. Sorry, I was
Okay.
talking to Mr. Peterson.
Okay, 11 times 3 times 2 times 5 times 2, right? This, if you can't think of a perfect square that goes into it, one strategy is to just take 660 and start with your perfect squares. And maybe start with the biggest one that could possibly, I don't know, I mean 36, probably not, but you take 660 divided by 36, is it even? No. So just move your way down. 660 divided by 24 is not a perfect square. 25 is. Nope. 660 divided by 16. Nope. 660 divided by 9. Nope. 660 divided by 4. There it is. But if you don't want to do the calculator method, just factor this to their primes. And then look and see with these factors if there's any factor here. If I multiply them together, I get a perfect square.
11 times 3 is 33, so no.
2 and
2 and 2 is 4.
Okay, so this is going to be 4 times 11 times 3 is 33 times 5, I think, is 165. Can I, are any of these going to give me a perfect square?
No.
No, but this will. So this is going to be 2 square roots of 165. And I can't simplify 165 any further for the perfect squares. Okay, did you get finished? You want to write your score next to your name up there?
No.
She did. She went up 10 points. Proud of her. Go on your score back.
Okay. You want to do another one?
Sure. Let's do a big number.
A big number. Okay.
Oh, that's a really big number. Okay.
So what strategy do you want to use?
I like that one better.
Factoring it?
Yeah.
Okay. So what do we know for sure goes into 6804?
2.
Divided by 2,
So
3402.
4 goes in there.
Okay. So this can be factored to 2 and 1701. Well, 1701 prime,
No.
3. 567. Is 567 prime?
No.
You want to try 3 again?
189.
Okay. Is 189 prime?
Yes.
You didn't do it by
No, it's not.
What's that?
63 and 3.
63 and 3? Okay, and 63 is 9 and 7,
Yeah.
right?
And 9 is a square root.
Yep. Okay, so my primes are, I'm going to start here with 2, 2, 3, 3, 3, 9, 7. Right? Okay, so this is a perfect square,
Right, so that's 4.
this is a perfect square, and this is a perfect square.
Right.
Does that make sense?
Yeah.
Okay, so I have 2,
Times this square root.
and this really is 81, isn't it?
Yeah.
So that's 9.
That's easy.
That makes sense?
Yeah.
Okay. The other thing you could have done, what was the original number, 6804? Divide that by, what's the biggest, I don't know, 81. 81 goes in 84 times. So I could pull the 81 out and then factor the 84. If you just think of a big, I mean, it may take some trial and error. And then depending on the number, this could have been faster, this could have been faster. It's kind of whatever your preference is. Okay. Kramer's rule problem. You want a 3 by 3 or a 2 by 2, Jared? 3 by 3? I'm making this up, so they're probably going to be.
Probably going to be a fun number.
Mm-hmm.
Wow. Okay, that gives me a headache.
I know. Okay, 3 by 3. So the denominator for each x, y, and z is going to be a 3 by 3 matrix.
Right, and it's going to be everything.
And it's going to be the coefficient matrix. And then here there's no y, so it's just going to be 1, 0, negative 3. Okay, rather than write that again, I'm just going to figure out what that value is. Okay, so with a matrix, with the calculator, I'm going to put a 3 by 3 in. I'm going to put in 2, 5, negative 3, 1, 3, 2, 1, 0, negative 3. And then I'm going to take the determinant.
Alicia.
And I get 16. Wow, it actually is
Look at that.
not a decimal or anything. So this is now 16. This is 16. Okay, right? On top then, it's going to be the exact same matrix as the bottom, except for the x. I'm going to put 14, 7, and 2, and then the others are the same. For the y, I'm going to leave the first column the same, and I'm going to put 14, 7, and 2, and then negative 3, 2, negative 3. And then for the z, the first two columns are the same, and then the last column. Right? And then you just plug each of these in the calculator and take the determinant, divide by 16, and you have your x, y, and z values. Okay. Personally, I like the inverse method better if I'm going to choose. It's faster.
Wait,
What's
what
the
is
inverse
this called?
method?
This is Kramer's rule.
Yeah.
What's that?
What do you mean the inverse method?
Well, for the inverse method, I'm going to take the inverse of this and multiply it by this 3 by 1.
Oh,
And I get the same answer for x, y, and z.
that's nice.
The inverse of this, the coefficient matrix, times this matrix, 14, 7, 2.
How do you find the inverse again on calculator?
Okay, so you put in the matrix, and then you pull up a clear screen, bring that matrix in, like this. So whatever your matrix is that you're trying to find the inverse, bring it in to your screen, and then raise it to the -1, which is this button here.
Wait. You go.
So you get
And then
the
enter.
matrix.
Decimal now.
Because the inverse has a decimal in it.
You can just change it to a fraction.
That'd be 5
Plug in the
halves.
matrix in.
No.
Or it could have lots of decimals like this one.
Oh, you divide them by
they-
2?
No, remember how to find the inverse?
I thought you just switched over, switched the side.
No, you take the determinant. So if I have this matrix and I'm trying to find the inverse, first thing I do, is find the determinant of this, which is 6 minus 0, divide it by that determinant, and then multiply it, switching these two and making these signs opposite. And then you bring this in. So this is 1/2, 0, -1/6, and 1/3. That's the inverse of this.
Okay.
Okay? And I told them if I give you a final question to find the inverse of a 2 by 2 as an example, I might write on the side saying do by hand, but you can check it by just plugging that matrix in and taking the inverse and then checking your answer and see if it's right. Okay? So we did simplifying radicals, we did Kramer's rule. You wanted to do matrix multiplication.
Yep. Oh, yeah, they're about neighbor. I just need to remember. Mrs. Hill and I were trying to figure out how to do it before. We spent the entire class period not all right.
So the first question, can I do this?
We don't know yet.
How did we figure it out?
So you have a 3 by 3 and a 2 by 3.
Dimensions?
And then if the
inside ones are the same.
The inside matches, I can do it, and my resulting matrix will be the outside,
Yeah.
a 3 by 2. Okay? So I know I'm going to have a 3 by 2. As the answer, right? But I just don't know what the blanks are yet.
Right.
Okay, so to do this, I'm going to take the first row by the first column.
Right.
2 times 2 is 4. 7 times 1 is 7, so that's 11. 1 times -1 is -1. 11 minus 1 is 10. And if it helps, just write it out. Then I do the second column. 2 times 7 is 14, plus 28.
It's like 30.
No, that's 42. 42.
And 1 times 3 is 3, 45. 3 times 2 is 6, minus 1 is 5, plus 0 is still 5. 3 times 7 is 21, minus 4 is 17, plus 0. 4 times 2 is 8, minus 2 is 6, minus 1 is 5. 4 times 7 is 28, minus 8 is 20, plus 3 is 23. That's matrix multiplication.
I understand it now.
Yeah. Oh, no.
I just needed a refresher.
Yeah.
Yep.
I'm ready for the final.
What other concepts?
Can we do like a square root over a number plus a square root?
Yeah.
Rationalizing the denominator?
It's I, -1, -I1.
Okay.
What?
The 4 iterations of I. I, negative 1, negative I, 1.
Actually, I'm gonna pass this final. If I remember those, I'll be good.
Okay, what do I do here? I cannot just multiply by the square root of 3.
With the conjugate.
I have to use the conjugate, which is 3 plus the square root of 3. Okay? I have to FOIL the top and the bottom, but the nice thing about the bottom is the middle term drops out because it's the conjugate. So on the top I have 6 plus 2 square roots of 3 plus 3 square roots of 2 plus the square root of 6. This cannot be simplified. The only time you could combine radicals is if the radicand, that number under the radical, is the same. It is not, so this is as simple as I can get it. The denominator, I have 3 times 3 is 9. 3 times the square root of 3 minus 3 times the square root of 3 is 0, so that goes away. And negative square root of 3 times the square root of 3 is negative 3. So the denominator is just 6. And this is my answer. If I can simplify, if I could pull a 6 out of everything, I would go ahead and do that. But this would work. This does not. This would to 1/3. This would to 1/2. But this does not. So I'm just going to leave it like this.
It would be complicated.
That's a big answer.
Yeah, I made a complicated problem out of that. You want to do one with I now?
Yeah.
Yes.
Okay, now we got to multiply.
Cannot just multiply by I or 3I.
You gotta multiply the conjugate.
By the conjugate. Okay, and so the numerator I must FOIL. The denominator, I'm not going to have a middle term, right? So there's a trick to just figuring out what this is, but if you're not sure what that trick is, then just FOIL it yourself and you'll see. Let's FOIL the numerator. 3 times 2 is 6. 3 times negative 3i is negative 9i. Negative I times 2 is negative 2i. And negative I times negative 3i is positive 3i squared. Tristan, you were one on the retake. You kept forgetting to square this I. Not bad, but I mean, if you recognize that you forget to do that, maybe you'll concentrate and remember to do it correct on the final. Because if you don't square it, then you ended up combining all these i's instead of recognizing I squared is negative
I
1.
remember that.
Okay? So just concentrate when you're doing this. Just take them one at a time. 3 times 2 is 6. 3 times negative 3i is negative 9i. Negative I times 2 is negative 2i. Negative I times negative 3i is positive 3i squared.
So it's negative 3.
Yes. This can go away. That becomes negative. Now I'm going to combine my like terms. 6 minus 3 is 3 minus 11i. So that's the numerator. Some of you, when you multiplied by the conjugate, thought the denominator just went away. It doesn't. You still have something in the denominator, but it's not going to have I anymore, which is the point of this.
Yeah.
Okay? So when I FOIL this, 2 times 2 is 4. 2 times negative 3i is negative 6i. 2 times positive 3i is positive 6i. My i's go away. And now what I've got left is 3i times negative 3i, which is negative 9i squared. Yes. Negative 9i squared is positive 9. So I end up with 3 minus 11i over 13. And then I've got to break it into a complex number, which does, I take the real part and the imaginary part,
Woo!
and I'm done.
Look at that.
I bet I could do this final.
Me too.
It's not.
It's not.
Yeah, we have 3
Okay.
minutes. 3 minutes.
I'll watch you get it done.
Feeling okay with stuff? Make sure you know how to graph from a line, how to graph inequalities, how to graph absolute value,
Okay, so for like a dashed line, it's when it's
not equal to.
okay.
Yep. And then use 0, 0 as a test point as long as 0, 0 is not on the line. If it's on the line, pick a point that's not on the line and use that as your test point.
Then we
Shade that side.
If it's not, then we go under.
Right.
Or whatever.
Or, yeah.
Okay, absolute value is always a V. If you graph an absolute value and it's not a V, you have done something wrong.
All right.
It's always a V. Huh?
I always, every time I graph, I'm just like, that verse can make it a V.
To find the vertex of the V, this V would start at what point?
Negative 2.
What point?
It started at 2.
It's got an X and Y coordinate. What's the X and what's the Y?
1x plus 2y.
No. No.
The x is 3 and the y is negative 2. I think she should.
The vertex begins at HK. What is HK in my problem?
2 and negative 1.
Okay, so that's where you start your graph.
Okay.
Okay? Negative 2, negative 1. This is positive. This is negative. So for H to make this positive, it had to be negative 2. Right? If I put it in this form, it would be X minus negative 2. Right?
Yeah.
So X is negative 2, Y is negative 1. So I start at negative 2, negative 1. I know it's going to be a V. This is my slope. If there's no number in front, my slope's just 1. But there is a number in front, so my slope is 3. Up 3 over 1. Up 3 over 1. But then I mirror that on the other side.
That's a lot smaller V than the one yesterday.
Well, the one yesterday had a fraction in front. The fraction squashes it down. The higher the number, the more of a sharp V it is. Stretches it up. If it's greater than 1, it stretches it up. If it's less than 1, it squashes it down. I don't know how else to say that. Pushes it down. Okay? Yes.